Okay, this is the review of the Readiness Assessment Test 5, the RAT 5. Here we go. First question was, please convert 6.78 miles to millimeters. This is a conversion. So the first step, as always, I like to do what? I like to start with the unit given. So I write 687 miles. Then, of course, I want to get rid of miles to get to kilometers. And the reason I do that is the conversion factor given to me was kilometer to miles, and they gave me the miles, and I want to go to meters. So the converting factor only converts my miles to kilometers, but I know once I get to kilometers I can get to meters. King Henry died drinking cat milk, right? So meters goes in here, and once I convert my miles to kilometers in this first conversion, okay, right here, then I know that all I have to do is get rid of the kilometers to get to the what? To get to the meters. And you should know that a kilometer is 1,000 meters. So it's a difference of 1,000. The what? Smaller unit, meter, to the what? Right, gets the larger number. Okay, so that's how you do it. So it's a two-step converting problem using the converting factor that was given right here, and I put the kilometer on top because I wanted to get rid of my miles. Notice the miles cancel here and the kilometers. So if you were to get this entire setup correct, what I mean by that is if you had all of this correct in terms of its setup, okay, then I would give you almost full credit. Because in this problem, I'm asking you to round correctly. Even though I don't say it, if you notice carefully, we start with 3 significant figures. And we should end with 3 significant figures. So we need to round. Now you say, well, why? Well, I'm taking a measurement, right, from a measurement device, and I'm getting 6.78 miles. Now I'm multiplying that by some converting factors, and this is important. These conversion factors, we did not measure. So if I was multiplying this by another measurement, we know to round to the least number of sig figs when we multiply or divide. But these numbers we did not measure. So we start with 3 sig figs. We should end with 3 sig figs. So when you're doing a conversion of any kind with one measurement, and using other converting factors you didn't measure, you always end up with the same. Okay? So it's important that you realize that. So my raw number is 10910.846, and there's more numbers to that. A lot of these numbers we're not very certain of because they were born out of multiplying this error times, right, this error in the ones place, times these converting factors. So I don't have much confidence that they mean what they mean. Where is my confidence in the number? In the first 3 significant figures. So I look at my numbers 1, 2, 3. I look at the second number. 0.1 is less than 5, so I keep 109. Notice the sandwich 0 is significant, and notice ending zeros don't count because there's no decimal point. So I round to the 109. Notice the number doesn't turn to 109. I have to have what? I have to have placeholders to make it come out that way. So the answer is 10900. However, in today's quiz, I had an extra 0 here, so this really should have been your answer. It should have been none of the above. So for those that got the correct setup and did not what? They put A and they forgot to round, I gave you plus 15, means you only lost 5 points out of the 20. If you, in fact, didn't choose C because you saw the extra 0 there and put E, full credit, okay? And that's how that worked. So moving down the scale here, let's go to number 2. And this was reading a, what we would say, a triple beam balance scale. And we read, just like any other measurement, all the numbers on the device plus the guess. So I'm certain of 20. I am certain of 27, and then I'm certain of these lines in the middle, 27.567. And now I'm going to guess, and it's hard to see, but in between these calibrations, I'm guessing. Since it looks like it's on the line, I'm going to guess that it's on the line. So I guess the 0. So I'm certain of 27. These are the numbers that I see calibrated, and I have my guess. You can't forget that, and that's why A is the answer. All right. So moving down, number 3. I gave you a bunch of measurements, and these measurements were measuring the same object with the same device by different people who know how to measure. And if you notice, all the numbers, calibrations on the device are being reproduced in every single measurement. What I mean by that is everybody's agreeing and everybody's certain of those numbers. What is different is the guess, and that's okay. The guess, as you can see in the above question, is an interpretation, is an opinion, okay? And sometimes those opinions won't be the same. But we say that this group of measurements are very precise, okay, because they are close to one another, and they only differ just by the guess, okay? So they're very close together. A group of 4 different people measuring the same object came up with the same results. Now, accuracy is dependent on how well these 4 numbers are close to the standard. And I told you the known value was 8.376. The ruler that was used to measure them should have come out to 8.376. But for whatever reason, there's a chip, there's a bend, the ruler might be warped. It was giving me results that were far away from this. Well, I guess it wouldn't have been bent to make it longer, but you get the point, okay? That these 4 numbers are not close to the known value. Accuracy is how close you are to the known value. So these are not accurate, but very precise, and that's why C is the best answer, okay? Going down to number 4, we have just a math problem where we're adding, maybe we're getting a perimeter of a, I don't know, a triangle or something, and we're adding 3 dimensions together, and we're just going to add them together, and we're going to get a raw answer of 914.268 centimeters. Remember, a number without a unit means nothing, and we have to round our results. The weakest number, of course, is this one because it has the least amount of precision. When you add or subtract, you have to round off to the least number of decimal places. It's about the precision when you add. When you multiply or divide, you round off the least number of sig figs because you're changing your result by compounding the error over and over. So you have to remember, addition and subtraction, it's the least number of decimal places. So because the tens place was the least number of decimal places, or the least precision, we round our result to the tens place. All right, so 6 is greater than 5. This makes this number bigger, so I should get 914.3 centimeters, and it's not listed. That's why E is the answer. And the last one is number 5. How many significant figures are in this raw number? And what this is about is, if I was to give you a number, not knowing the device it came from, how many numbers were actually measured, and how many zeros are actually there to make the number big or small. What we mean by that is which ones are placeholders. So I know that zeros that are in between non-zero numbers are significant, so I definitely know that there is 1, 2, 3, 4. Now, does this 0, was it the guess in the measurement, or is it there to make it big? Well, without a decimal point, the ending 0 does not count, so this has 4 significant digits. If it did have a decimal point, then that means that that was the guess on the device, and it is significant, and it would be 5. But because there was no decimal point, all right, it only has 4 numbers that came from the device, and it includes the guess. All right, hope that helped.